Hello and welcome in. Mark here, aka, aka the Markster. This is video number 31 in the FreeCAD series. I recently updated FreeCAD, so now I'm using 0.19 19758. It's the latest and greatest available among the precompiled binaries on the GitHub repository for FreeCAD. So this is still a developmental release, sort of a beta release if you will, and I'm using on Windows 10. So today we're going to start looking at Part Design Workbench, and we'll create that first model that we made, the tube model. Let's do it in Part Design. So that'd be kind of our hello world model. So I'm going to use dynamic data to store the variables instead of a spreadsheet. We go to Part Design Workbench, and for Part Design it's a little bit different from Part, but there are a lot of similarities. The first thing, don't read too much into the Part Design name versus part name. It's just a name, and I really don't think it has much significance at all, as far as one's more for design and one's more for something else. I don't really buy that logic. Maybe, but it's not really. I don't think the name, don't read too much into it. So the first thing you do with in Part Design is you have to create a body, and this is, since 0.17 this became a requirement. So every Part Design model needs at least one body to contain the object. So the body is sort of a container object in a way, kind of similar to the part object here. This one we talked about in a previous video. Some similarities there, I think, but you can think of it like this: the body is the solid, and it will have features making up that solid. So let's we can create a body, but another way to do this, create a new sketch with this icon in Part Design. It will make the body for you and put the sketch in the body. So that's how we'll do it today, and we'll choose the XY plane. Alright, and I'm just going to pad a sketch of two concentric circles, one representing the inside of that tube, one representing the outside. And I'm going to create some variables in the DD object. Switch here to the Model tab, create a DD object, and we need a length type property for the outer radius, and that's going to be a 1/2 inch. And you can enter some expressions here in the dynamic data. So 1/2 times inch makes it 1/2 inch, and you can add your own tooltip if you want. Optionally. So we see it added DD to the name, and it created and it initialized it with a 1/2 inch in millimeters. And we need, what else? We need the wall thickness. And that was 1/8 of an inch. You can use inch or inches, either one. And this is tooltip is optional. Notice the wall thickness of the tube. Alright. So now we have two variables. That's really all we need. Oh, we need a height also. There'll be another length type. And this will be height. And this was 4 inches, I think, in the original. Alright. Now we have our variable set up. We'll go back to the sketcher. And we'll set this radius here as dd.dd outer radius, and the inner radius, that's going to be the outer radius minus the wall thickness, right? And now we need to pad our sketch. The pad feature is basically the Extrude tool, same thing from the part workbench. Not exactly the same thing, but it does the same basic thing. And we can access the formula editor here, and that's going to be our height, dd.dd height. And you have symmetric to plane and reverse, and an option here to extrude or pad to a particular face that you can select. In this case, this is what we want. So basically we're done, and we've got all of our parameters here. And what's nice about this is we can make changes and see them happen right away and see what difference it made without having to switch back and forth between the spreadsheet covering up your view until it recomputes, or press F5. So that's 50. That's going to be too big. That wall thickness is too big for what we have going here. 5, let's try that. F5, yeah. You can't make longer than your radius. So that was the reason for that error. Alright, now let's look at some different ways that we can make this in part design. We have a revolve tool. We can revolve a sketch like we did in part, and one of the ways that we made that model, I think when I first introduced the sketcher, we made it by revolving a sketch. So we already have a body, so I think we need to create a new body, make it active, and now we can make a sketch. And we want this one on the XZ plane. What was that? Let's make sure, yeah, we're mapped to the XZ plane. And this will be like a rectangle off to the side that will revolve around. Let's catch that horizontal axis there. And this will be our wall thickness here. There's the equals key, dd.dd, our wall thickness. And this will be our outer radius from here to there. Outer radius. And our height is way off. Equals height. And it looks like we need to set this on that edge. Alright. Close that up. And let's revolve the sketch. The vertical axis is the default, and that's the one we want in this case. We could select different axes. Right here, choose select reference. That's the one we want. So let's compare these two now. They are the same, you can see. Just another way of making the same model. So we have two different ways. And we have a third way too, using a primitive based approach. You can do primitive based modeling here in part design. Let's create another body. Now my active body has an overline and an underline. That's a little tweak I did to give me that, just so I can see better at a glance which one is my active body. I don't remember exactly which setting I had to tweak to do that. Let me put it on pause and I'll figure that out, and I'll come right back and let you know. Okay, here's what you need to do to create this overline and underline effect here. You go to Tools, Edit Parameters, and we're going to look at Base App Preferences, Tree View. And here you need underline and overline set to true. If you don't have these, which you probably won't, new Boolean item, and name it tree active overlined, set it to true, and then right click here, new Boolean item, tree active underline, set it to true. And you can also have tree active bold, tree active italic, and the colors can be set in preferences. So that's the parameter editor. And in preferences, which is an edit menu, we'll look at output window. It's not, okay, no, that's not it. Display colors, there we are. Display colors, and look for active container. So you can set your color of your active container to some color, like we can make it red here. And that didn't work. So edit preferences, display colors. Must be some other setting for the color. I thought this was it. Okay, there we are. So now I can tell at a glance very easily which one of my bodies is active. Alright, and we can make this with primitives. So right here we have additive primitives, and here we have subtractive primitives. So in general, the yellow icons are adding things. So the pad adds something. Pocket is just like a pad, except it removes. So it's like extruding and part workbench and then cutting. So that's what the pocket does. Kind of does both of those operations in one way to think of it. And this is the revolve that we used a moment ago. Groove is the same thing as revolve, except it's like a subtractive revolve. So it does a revolve and then cuts it away from what you had before. Then you have the loft and sweep, additive and subtractive versions of each of those two. So we're going to make an additive cylinder of the outside part, the outside cylinder, and a subtractive cylinder of the inside part. Probably the problem here is they're both the same size, so we don't have any material left. So let's set this inside cylinder to the outer radius. And we'll set this height while we're here. ED height. And now the inside one, let me clear this error here. So now we've got something working, it's just too short. Equals the height. And now we need also to set that internal radius. So this was the outer radius minus the wall thickness. So we've got basically the same object in 3 different ways. Not crazy about that red color, but it does make it pretty easy to determine which of these objects is the active body, because the active body is going to be where your new feature is going to go. It's pretty important to be able to see which one is active. Alright, now there are other ways we can make this too. We could have 2 different bodies, an additive, 2 different additives, and then do a boolean on there. Do we want to do that? Yeah, I guess so. We'll show. It's a kind of a contrived thing because it's not how you would do it for sure. Let's create a body, and this will be the outer part. Let's go ahead and set our radius, outer radius, and the height equals dd.dd height. So this is our outer part, outer body experience. And let's make a new body for the inner body, and we'll make another additive cylinder. And this one is going to have the radius as what is this, outer radius? Lost my little pop-up list here. dt.dd outer radius minus wall thickness, and the height will be dd height. So now we have so we're going to make the outer body active. Then we'll click the boolean operation here, and the operation we want here is cut, and we'll add another body, and the body we're going to add is this one, which is the inner body. It hid the body that we're actually in, our active body, so the only one visible here is the internal part. And then OK. So we have a boolean operation between 2 different bodies. The outer body is cut, a boolean cut, with the inner body out of it. That's a mouthful. I don't normally use these boolean operations here in the part design workbench. You don't really need them that much because You can do your additive and subtractive right here with these tools. But here's another way to do it. It's not nearly as clean. Look how clean this model tree is for this body object here. You just have a sketch and a revolution. And this one is a cylinder and then a subtractive cylinder. But this one here is kind of a mess, huh? Let me delete this boolean. So now we have two bodies, and we can use part module, part workbench, boolean operations on these bodies. Just remember, don't do it on the feature. Always use the body for your part workbench operation. The body is the solid, and the internals, those are the features. So use the body. So outer body first, that's our base, and then body 4 is our inner body, and we do a boolean cut. You can mix and match part and part design objects. It's not generally recommended, but you can do it. Just remember, access only the body objects. And you can't really use these fillet tools and chamfer tools because you can't really select just the body. You'll end up selecting a feature here when you select in 3D view. But you can use the boolean operations if you want to. To me, this looks a little cleaner. Call this one inner. The tree looks a little cleaner. And you can expand the bodies to see what each one of these is. So whatever you prefer. Most people strongly recommend, if you start in part design, stay in part design. If you start in part, stay in part. But you can mix and match. These tools here, these are the array features. You have one of the things lacking in part is the ability to do arrays. Well, you can do them right here in part design. One problem is they're not as efficient. Even though part design is coded in C++ and draft workbench is coded mostly in Python, you would think C++ would be faster, but it just hasn't been optimized quite well enough. So you'll see a noticeable performance gain by using part workbench and draft arrays as compared to these arrays here in part design. So this is a mirror tool, very similar to the mirror tool in part workbench. This is a linear array, so you make an array just a line in a row of objects, or features actually. This is a polar array of those features, and we'll use these in later videos. And this is a multi-transform feature. So what this does is it enables you to add multiple arrays into one object to get the equivalent of three-dimensional arrays. This is a fillet tool. It works very similarly to the one in part. This is a chamfer. This is the draft. So what the draft does is it enables you to change the angle of faces. And this is a thickness tool. So I suppose that would be another way to make this tube, is to apply thickness to a primitive cylinder. Let me create a new body first. And add a cylinder here. We'll accept these defaults. It's outer radius and height. Now select these faces and try this thickness tool, and we want to go negative here. Let's see, minus wall thickness, right? We could make thickness inwards. Let's see if the negative part works. Yeah, so that works too. Or make thickness inwards, that would work too. Like in part workbench, the thickness tool can be kind of contrary. And I'm trying to think of another way to make this. I guess we could loft two sketches. You can use sketches that have two circles inside, one inside the other, with the loft tool here. You cannot use that in part like that. It has to be just one wire. So one advantage of that part design has is that loft tool is a little more flexible. Let's do that, I guess. Create a new body, a new sketch on the XY plane. Let me switch to the model view and hide. Let's hide that body there. And we'll make a sketch. Two concentric circles. This one will have outer radius. This one will have the inner radius. Now one thing to look out for when using this loft tool is the order of creation of your circles is important. The order of creation. If you make one, the first one outside and the first one inside, they're going to cross and you'll end up with a self-intersection. So if that happens here, I know what to do to fix it. And this will be the internal one. So that's what, outer radius minus wall thickness. There's about a 50-50 chance we're going to run into that issue. So that's sketch 2, and let's make another sketch. Also an XY plane. And let's just carbon copy. This is it right here. Just carbon copy these in. So that would prevent us from having a problem also with the cross wires there. So this one we need to move it up some. So adjust the attachment offset in the Z direction by the amount of height. So you see we have two sketches, and we'll just loft between those sketches. Use the loft tool here. At least one section is needed. Okay, so sketch 3. Which one is sketch 3? 2 and 3. So this is 2. So we need to add a section. Is this the one to add? Nope. Remove a section. We need to add the other one. There we are. We see a little preview. What's going on there? Let's clear this. And okay, so now we've got the Loft Tool. The Loft Tool technique. And we can sweep a tool also. You want to sweep a tool? Use a sweep tool, sweep a sketch. Create a new body. Create a new sketch. XY plane. Let's see if we can just copy the you have to make the body visible. We'll hide this loft. There we are. And switch back to the task. And we'll do the carbon copy trick again. But why is it not letting me? The reason is to copy from another body, you need to hold down the shift key. Is it shift or control? Control key is the one. And now we've got our sketch. Oh, show this one and hide this one. Alright. So I actually have the top sketch there. Now we need to have another sketch. It's going to have a path to follow, right? Or we can use this datum line. I don't think the datum line is going to work right here though, because this is going to be, I don't think we can set the length to a datum line. I don't want to select anything from that body. Select the sketch. But this is not going to work, I don't think, because there's no way to tell it how long to make the datum line. It'd be great for giving you the direction to sweep in, but not. We'll have to make another sketch. Not how long to do the sweep. So let's make a sketch on the XZ plane for our path. And we just use a line segment. And the length of this line will be what? dd.dd height. Okay, now let's see if we can sweep along that edge there. It's giving me an error because I don't have the spine linked yet. I guess we could select both at once here. Let's see, clear this. And then do the sweep. No, we didn't like that either. Add the edge here. And what mode do we want? Probably doesn't matter in this particular case. Guess I swept in the wrong direction after all. Oh, it flipped that sketch around on me. That's what it did. If you make it minus there, what does that do? Alright, let's try that now. Yep. Now we're in the same spot. So those are 6 different ways to make this little simple tube in part design, and there are probably other ways to make it aside from the ones that I've shown you here. The best way, in my opinion, is the first way, where we just pad a simple sketch out to the height that we need. But that's gonna do it for today. Pretty good introduction to part design. Still some tools that we need to talk about later on, and using these arrays. But the main thing with part design, once you learn part, it's not that much, a few things are different. You have to have a body. All of your objects have to be contiguous within the body, so you can't have parts that are not touching one another in a body, or else you'll get an error. So you need a separate body for non-contiguous parts. So you need to design your model from the beginning with the notion that all the parts are going to be connected somehow. And we'll talk more about that as we continue using this workbench. In part, you don't have that limitation. So we could have, for example, let's create a new body here. Hide this one. Put it on the XY plane. So in part, we could have this and extrude that, and it will work just fine. But in part design, I said no. These are not creating one contiguous solid. The result has multiple solids. This is not supported at this time. So you have to keep your sketches where you have one outer wire containing the entire thing. That's one of the limitations. Let's see if I can drag this out of here, out of this body, go to part, take the same sketch and extrude it, and it's going to work just fine. So one of the limitations of the part design workbench is it has to be one contiguous solid. So think of it like an ant crawling over your model, or a snail crawling over your model. It has to be able to get from any point to any other point without hopping. It has to be one solid piece. Now, it doesn't mean you couldn't have a model where, for example, you had a plate and you had 2 cylinders sticking out of it. You just have to do the plate part first. So let's go there and let me show you. I don't want to create it here. I can drag it here. Let's just create it, import design. So it gets added to our body. And XY plane. So we're gonna have like a plate that these two cylinders would be extruding out of. And do our pad first. Do it in the reverse direction. And then the other one could be, now you can pad this one. It just has to be at every point in the process, you have to have that one solid body. Notice there's no need to Boolean fuse these together. It's all one body, one solid. The body is a solid, and these padded features, these are the features. So if I wanted to cut a hole in here, we can add another I don't know why it keeps flipping it upside down on me. Map reverse there. And we can use pocket. And we can use pocket through all, symmetric to plane, both directions. So no Boolean operations really needed usually. If you do, it's two different bodies. You do the Boolean on two different bodies. Otherwise you just use the additive or subtractive features, or additive or subtractive primitives here, or do the Boolean on two different bodies. So like one is your active body, click on it and then add another body to it. Okay, so we covered a pretty good bit today. Hopefully not too much at once. We still can talk about the shape binders and stuff that we haven't covered yet, and we'll cover all these tools in later videos. So that's going to be it for today, for real this time. Thank you for watching, and have a great day.